Hi everyone, I am Shubham Jhanwar. We are discussing KVPY 2017 SX, and this question for this video is this. Let in equal to integral 0 to 1 e to the power minus y to the power n dy, where n is a non-negative integer, then sigma n equal to 1 to infinity in by n factorial is. Four options, single correct type question. Let's solve it. So here in is equal to integral 0 to 1 e to the power minus y to the power n dy. So let's say this is the second function and this is the first function, and let's go by using the method of by parts. So here in is equal to, you have minus e to the power minus y to the power n, 0 to 1, minus minus becomes plus, and you have n integral 0 to 1 y to the power n minus 1 e to the power minus y dy. So if you see carefully, in is equal to, when you put y to be 0, it vanishes, and when you put y to be 1, it's essentially, you may say, minus 1 by e, plus n times, if you see carefully, this is in minus 1. So what you have is in minus n times in minus 1 is equal to minus 1 by e. And what we are looking for is sigma in by n factorial. So let's divide this entire equation by n factorial, and I have in by n factorial minus in minus 1 by n minus 1 factorial is equal to minus 1 by e n factorial. So now if you put n to be, let's say, 1, you get I naught, because since this n is supposed to be non-negative integer, but still we will not take n to be 0. Why? Because in minus 1 is appearing here. So when you put n to be 0, I minus 1 doesn't make sense. Because the subscript of in is supposed to be non-negative integer. So here n is supposed to be greater than or equal to 1. So we are starting with n equal to 1. We put n equal to 1. We get I1 by 1 factorial minus I naught by 0 factorial is equal to minus 1 by e 1 factorial. When you put n to be 2, you have I2 by 2 factorial minus I1 by 1 factorial is equal to minus 1 by e 1 factorial. My bad, 2 factorial would come here. So when you put n to be 3, you get I3 by 3 factorial minus I2 by 2 factorial is equal to minus 1 by e 3 factorial. So this can keep on, we can keep on going like this, and as we add, I1 by 1 factorial will cancel out, I2 by 2 factorial will cancel out, so on and so forth. But that's not what we want. What we want is sigma n equal to 1 to infinity in by n factorial. We can get in by n factorial in terms of minus 1 by e, minus 1 by e divided by 2 factorial, so on and so forth. But if we can directly get sigma n equal to 1 to infinity in by n factorial, that would be great. So here let me say this to be equation 1, let me say this to be equation 2, and let me say this is to be equation 3. So here if I proceed, I mean, you can keep on increasing the value of n like this, and we can keep getting the equations. Essentially what we'll be doing is, we'll be doing equation 1 plus 2 times equation 2 plus 3 times equation 3 plus 4 times equation 4 if we would have written that, so and so forth. So if you see carefully, what you would be getting is, you would be getting here I1 by 1 factorial on left hand side. If I talk about I1 by 1 factorial minus I naught by 0 factorial plus 2 times I2 by 2 factorial minus 2 times I1 by 1 factorial. So I get minus I naught by 1 factorial, I1 by 1 factorial minus 2 times I1 by 1 factorial is minus I1 by 1 factorial. My bad, I naught by 0 factorial it would be. Of course 0 factorial, 1 factorial, both are 1, but for consistency and for exactness, let's call it I naught by 0 factorial. Similarly, 2 I2 by 2 factorial minus 3 I2 by 2 factorial. So you get minus I2 by 2 factorial. So and so forth, you would be getting, right? Minus I3 by 3 factorial, minus I4 by 4 factorial. This is what you would get on left hand side. What about right hand side? The right hand side would be, you would get minus 1 by, if you take common, you get 1 plus 2 times 1 by 2 factorial is what? It's 1 only. 3 times 1 by 3 factorial is 1 by 2 factorial. Similarly, 4 times 1 by 4 factorial is 1 by 3 factorial, so on and so forth. So for clarity's sake, let me write n equal to 4 equation also, so that it is even much more clear to you. So I've written this for n equal to 4. Let's say you get the equation 4, and what you have is plus 4 times 4th equation, and so on and so forth. So here let me write one more expression here also. So you get minus I3 by 3 factorial. How? You get 3 times I3 by 3 factorial minus 4 times I3 by 3 factorial. So, yeah, so and so forth. So on one side you get you are getting minus I0 by 0 factorial. 0 factorial is essentially 1 only. So you get minus I0 minus s, if I call this expression to be, let's say, s, whose value we want to evaluate. Yeah, I1 by 1 factorial plus I2 by 2 factorial plus I3 by 3 factorial, so on and so forth, infinitely many terms. So you get minus s is equal to minus 1 by e. If you see carefully, this 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial, so on and so forth, is essentially e only. Because what is the what is the expansion of e to the power x? E to the power x expansion would be what? If you consider, let me write it here, e to the power x expansion, it will be 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on and so forth. Now when you put x to be 1, you get 1 plus 1 by 1 factorial, which is essentially 1 again, plus 1 by 2 factorial plus 1 by 3 factorial plus so on and so forth, infinitely many terms, mind you. Yeah. So here this essentially is 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial, so on and so forth, is e to the power 1 only. Now to find s, we also need to find I0. So what is I0? I0 is essentially integral 0 to 1 e to the power 0, which is 1. Yeah, e to the power my bad, y to the power 0, n is coming here. So e to the power minus y times y to the power 0, n is 0, right? So y to the power 0, here it becomes 1 dy. So what you get is e to the power minus y minus limits 0 and 1. So what you get is minus 1 by e plus 1, right? Yeah. So essentially what you get is here s is equal to 1 minus I0, 1 minus 1 by e. So here it essentially becomes 1 by e. So C is the answer. Thanks for listening. Stay tuned.